Hey everyone, Sean here for Lambda School. And the last official sprint that we finished was the server authentication sprint, where we implemented server-side authentication using sessions in our Express servers. And so now to kind of wrap up that discussion, we'll be going into client authentication, or having our client tie in to our authentication server, essentially. So the topics we'll be touching on are sessions versus JSON web tokens, which are two different ways to handle client-side authentication. We'll be talking a little bit about local storage, what that is, how to use it, CORS, or cross-origin resource sharing, and then lastly, we'll touch on React higher-order components as well. All right, so first off, sessions versus JSON web tokens. So JSON web tokens are pretty much what they sound like. They're a token that's issued by our server that is saved locally client-side, and it persists as the user navigates through the client. So really just think of it as the alternative to using sessions, where when we implemented sessions server-side, when a user logged in successfully, we stored their session data in our server as part of the user's state, right? So JSON web tokens really are a client-side analogy to sessions, where instead of just storing that session data, on the server, it's stored as a token, or it's issued as a token from the server. So the server hands the token to the client persists it, and then that JSON web token is what is used basically as a proxy for the client's state, or session state, basically. So the typical flow of the life cycle of a JSON web token goes something like this. The user logs in the client through a post route to the server's login route. And then once the server is authenticated and authorized the user, the server sends back the JSON web token to the client, which the client persists locally, typically using local storage, which we'll get into in a second. So then whenever the user makes a request to the server for a restricted resource, the client sends along its token as part of the request. In order to communicate to the server, the client has a valid session and is thus authorized to access said resource. And then finally, when the user logs out, or posts to the server's logout route, essentially, the server revokes the client's token, basically. So inside the server nullifies that particular JSON web token. So the server nullifies it, and then the client, on the client side, inside of local storage, the client also nullifies its copy of the JSON web token, so that both parties have now agreed that this token is no longer valid or usable. And so the next time that the user logs in to the same server, then the client will be issued a new JSON web token. So again, that flow looks something like this. If we were to draw a handy little visual of it, client posts to server's login route, the server sends along the token, which the client then persists inside of local storage. And then whenever client makes a request, it sends along its copy of the JSON web token that the server then checks against to ensure that that token is valid, which then ensures that the client is able to access restricted resources. And then finally, the client logs out. So the server nullifies its token, and in local storage, it's also nullified. So what are some of the trade-offs when talking about, JSON web tokens and sessions? One of the main benefits of JSON web tokens is that, the fact that the server offloads the handling of state onto the clients. So it would make sense then to utilize JSON web tokens when, for example, we're trying to scale our application out horizontally, like as wide as possible, where we want to, say, reach as many clients as possible, right? Like we're expecting that a lot of clients will be connecting to our server and using our server's, routes or its API. And so in that case, it makes more sense to use JSON Web Tokens because, because we have a lot of clients, we don't want the server to have to handle all of that extra, session data, essentially, right? So if we could instead offload all of that extra work onto the clients by having the clients persist their session state via JSON Web Tokens, then the servers, there's a lot less overhead on the servers. And we place a lot less burden on the servers to maintain all those individual session data. On the other hand, the benefits of using sessions is that we get to keep the client side as dumb as possible, right? Because then the client, all it's responsible for, if it's not responsible for helping to maintain session state via JSON Web Tokens, then the client, that's another layer of complexity of the client that we don't need to handle on the client, right? Because that's just then handled on the server, and the client doesn't need to worry about that at all. And so really, if you want to keep your client as dumb as possible, if you will, then sessions are the way to go, are offloading all of that state maintenance onto our servers. And as you guys maybe something you guys can relate to is, from a development standpoint, implementing sessions on the server side is slightly simpler than, adding on the layer of complexity onto the client side as well, of saying, the client has to now be able to know how to handle the tokens and access local storage and all that extra complexity. Whereas if we just did sessions, then all of that is siloed within the servers, and whenever we want to change how, for example, if we want to change how we handled sessions, or we need to change some of that session maintenance logic, for example, all of that is just handled within the server. We don't need to go and touch the client. Okay, so from here, let's go on to talk a little bit about local storage, which I was alluding to earlier. So local storage is typically what is used in order to persist JSON Web Tokens on the client side. Right, so the local storage really is nothing more than just a simple key value store that is made available on all of today's modern browsers. And the API for using local storage is, pretty simple. It's pretty much what you would expect of like a normal hash table, if you will, right? It has the canonical methods on it of, set item, and you input key and value. You get item, and then you have a remove item, right? So let's just do a quick little example here. And so you can access local storage from inside of the Chrome developer tools. If you go to application, and here you'll see local storage. And right now you'll see that there's nothing inside of the local storage. It says key value. And so we can go to the console and play around with our local storage, right? So here we're saying set item called token to be some illicit string, enter, and then inside of application here, we'll see token is now available, and the value is right here inside of local storage under the application tab. So now we can do get item token. That gives us back our value. And then finally, we can remove said token. And check again inside local storage, and now it's been removed. So it really is as simple as that. If you want to access local storage from, for example, inside of a React component, you really just access local storage as you would exactly in the console. And so you can manipulate local storage, the key value store, local storage from inside of your React components. And so the way that would work then is you would tie that. So this, once your server, or once you connect your React components or your React application up to the server, and then you would need to hook it up such that within your actions, for example, once the data got returned from the server, because the server would return the token, then inside of your React application, you would say, local storage dot set item token with whatever token the server handed you back, the JSON web token that the server handed you back. Cool. So now let's go on to talk about CORS, which stands for cross-origin resource sharing. So CORS, and not even really CORS itself, but by default, browsers don't allow requests between different origins to be fulfilled, right? So what does that mean? What is an origin, right? So that's what this table is showing. There's something called the same origin policy. You can Wikipedia that. Same origin policy. That's where I took this table, and it is this table. But this is basically showing, what is comparing. So it's saying, take this URL, www.example.com/dir/page.html as our, root domain or our root origin, and then compared to a bunch of other URLs, what is considered by the same origin policy to be the same origin, right? So this first one is the same, is considered the same origin success. And the reason, same protocol host and port, only difference here being was, a different page 2.html. Other than that, the domain and the port and the protocol, HTTP, is the same. Same with the second one, different directory, right? So again, same protocol host and port. And then in this third one, again, it's still the same protocol, HTTP, host, and port number, even though it's accessing a different, I forgot the word. Well, anyway, I'm blanking on the word right now, but then they go into a bunch of examples of what is not considered same origin, right? And so when you alter the port, then that's not considered, you're no longer considered to be in the same origin. Basically, as if you alter any of the three criteria of protocol, host, and port, then you're no longer to be considered the same origin, right? And so that's why even when we're trying, and maybe some of you have run into this inside of your greenfield projects, for example, where you've been running into errors when trying to make requests from a client to an authentication server, and it's telling you that access is not allowed because you're not following the same origin policy, essentially. This is kind of the reason why, but because it's because even though we're on the local host domain, because we're doing it all locally within our computer, we're forced to utilize different ports, one to run our server and one to run our client. And so because we're using different port numbers, then by the logic of the same origin policy, we're not originating from the same origin. And so CORS needs to be utilized in order to perform that cross-origin resource sharing. So CORS is required in certain cases. Right, so the way to get around the same origin policy using CORS, so we have a CORS middleware that Express.js includes. And I know some of you guys have been using it already inside of your greenfield projects, but if you haven't, it's a pretty simple, drop-in middleware solution. It's really easy to kind of just add to our node servers. So if you just npm install CORS, then require CORS inside of your server.js file, then you can just say app.use CORS, and now all of your routes can be accessed from separate origins. You can also enable CORS on a single route by dropping it in as local middleware. And typically this is what you would want to do inside of like a production API, because typically, you wouldn't want to expose every single one of your routes to be accessible from a separate origin, right? Like there are times when inside of your production API, you want certain routes to be private, to not be accessible from outside, like your organization, for example. But for the purposes of this particular lab, it's just easier to say, hey, server, let all of our routes be CORS enabled, just because, you know, we'll be using most of the routes from our auth server. And then there's more stuff here about configuring CORS and stuff that you guys can read about. Lots of good stuff here. Cool. So that was everything I wanted to talk about with CORS. And then last topic that we are to go into are React higher order components. It's a bit of a shift. We're not really in the realm of client-side authentication anymore. React higher order components don't actually have anything to do with authentication, but it is something that, it is a concept that we'll be tying into this particular sprint. So, you know, you'll be implementing a higher order component within the context of the client auth sprint. So first off, you know, what is a higher order component? So a higher order component is, or the main purpose of a higher order component is basically to encapsulate functionality that needs to be shared between different components that maybe typically don't actually have anything to do with each other. So the main example of why we'll be using higher order components in this particular sprint is there are certain components. Sorry, let me go back to components. So we'll have all these different components, and some of them we only want to be accessible once authentication has been cleared. Okay, and so what that basically looks like is if we go into index.js. So we go inside index.js here, you'll see in particular users is the component that we only want accessible once the user has been, or the client has been authorized or authenticated. Right, so here we're including our require auth higher order component, and then we're wrapping that around this users component. And I haven't told you anything about what this require auth component is even doing yet, but just from the naming, I think you can kind of guess that once we wrap users inside of require auth, that there's some logic that require auth does first to ensure that our user is authenticated before the user's component then gets rendered. And so really you can think of it as, you know, this is really analogous to middleware on the server side in a way, right? So if you think of users as just like a user's route, for example, that is a protected resource, require auth, then you can think of it as, you know, a piece of local middleware, very much like what we had done, like the check restricted route that that maybe some of you implemented inside of the auth sprint, that would check first when someone tried to access a restricted route, checked first to see if they were logged in, and then only then would it grant them access upon ensuring that that particular person was logged in. So you really can think of this particular higher order component as doing exactly that, checking to see that the client or the user has been adequately authorized before they can then access this user's component, right? So let's take a look inside the skeleton of the component itself. So this is a component that you'll be implementing, though there is some skeleton code and some comments to kind of help you along the way, right? So kind of the structure of a higher order component is that a higher order component is actually just a function that takes in the component that we want to basically extend, right? So here we see export default, and then this higher order component accepts a composed component as its only argument. And here the composed component is that user's component that we saw that require auth was wrapped around, right? So our require auth, this component is called require auth. This higher order component is called require authentication, right? So the name here, and then we wrap it around a composed component user, and then it adds or extends that component that was dropped in with some additional functionality. Oh, sorry, require authentication here extends component, right? And so you'll see in the comments here, when this high order component mounts, we want to check to see, there's a check authenticated action that simply returns a Boolean for whether or not the client right now is authenticated or not. So you'd want to use that, you want to invoke that, or you want to, sorry, there's a props, this dot props dot authenticated, which is a Boolean, and you want to check that to see inside of component will mount if that was true or false. And if it's false, meaning that the user is not authenticated, then you'll want to redirect them to the proper page, in this case, sign in, for example. And then inside of render, which might be a little misleading because this higher order component doesn't actually render anything. It simply, gates another component. So what that means then is, again, check to see if this props authenticated is true or not. And then if it is, or if it is not, then we don't want to return anything in our render. Like, we don't want to render the composed component, or we don't want to return the composed component, right? Because the composed component needs to be blocked off if the user is not authenticated. So basically here, if you check to see that the stuff props.authenticated is false, then you basically will return nothing or return null. And then inside of else otherwise return, render the composed component or return the composed component. That's what this particular higher order component is doing. But higher order components are, I've been talking about them within the context of this particular sprint, but they're way more general than that. The overall pattern of a higher order component is simply, a function that accepts another component and extends its functionality in a way, or gates it in some way, for example, right? So, and again, the most useful case for higher order components is when you have a bunch of components that you want to mimic functionality between, but that, these components may not necessarily actually have anything to do with each other, right? So we can think about it again as, if we go back to index.js, let's say, let's just pretend, we could just pretend that users wasn't the only component that we wanted gated behind authentication. We could have a whole bunch of others. Right. And then so in that case, that's when the require auth higher order component really becomes more useful, because then we can just wrap all those other components within require auth. And we wouldn't need to go and implement that logic to check that the client is authenticated individually inside each of the different components. Right. Okay. So hopefully that makes sense. All right, then let's go and talk about the mini a little bit. The mini here is pretty short. There's some stuff you'll need to do with your auth server. So for example, you need to go and add cores to it. There are some additional routes that we need to add to it to have it work with the client auth sprint, because this is right now expecting some routes that you were not tasked with implementing inside the actual auth sprint. And so the mini is having you go and do that. So you add a logout sprint, you add a logout route, you add cores, and then if you didn't get around to adding like the /restricted/users route, then you'll go and do that here. So it's pretty short, and then, of course, making sure to test your routes in Postman to ensure they work as expected. But yeah, so not too much to actually do here. And so, I'm expecting most of you guys to finish this pretty quickly. And so if that's the case, then there's a bunch of articles here that touch on and go more deeply into all the different topics that we've talked about so far. So some analysis on web tokens, some more analysis of web tokens versus sessions, a deeper dive into cores, and another article here talking about higher order components goes into that a lot more in depth than I was able to within the confines of this lecture. All right, so that's the mini. Should be pretty easy this time around, nothing crazy going on here. But yeah, so those are the topics we'll be covering in the main lab. Yeah, so the main lab, we chose to have you guys use sessions to implement client-side auth using sessions. But then there is basically an extra credit bonus sprint here where you'll then clone down a separate server that is configured to issue JSON web tokens. And then inside this extra credit, you'll basically refactor your client. You'll basically refactor your client to then use JSON web tokens. And then if you get that far, there's an insanity mode where we encourage you to basically rebuild all of this entire client from the ground up, from scratch, basically, because it's, you know, this is like a pretty typical React Redux application. But we've given you guys a lot of starter code because maybe it's been a while for some of you since we touched React and Redux. And so we've provided a lot of that starter code for you guys right off the bat. But if you do get around to finishing, then you definitely should try to build out all of that on your own, just to really refresh your memory and, you know, get in more reps, if you will. Alrighty then. Cool. That's it. And good luck with the sprint, guys.